Hello and welcome to my video on the Nintendo Game Boy Advance. In this video I'm going to talk about some of the technical capabilities of the Game Boy Advance, and then I'll finish off with a demo showing tile mode 1 with some 16 color tiles on one layer and 2 layers with 256 color tiles and some sprites to top it off. So let's get into it. So we've got the standard Game Boy Advance here on the left and the Game Boy Advance SP on the right there, which has a more compact frame than the others. So most of the info here is from Wikipedia and also from coronac.com, specifically the tonc lib library, which all of my code will be based on top of, basically going forward in all my Game Boy Advance tutorials. So the Game Boy Advance is obviously a successor to the Game Boy and Game Boy Color. It was first released around the world in 2001 and then finally released in China as the IQ game in 2004. So it's got a 32-bit CPU inside of it, but for some reason Nintendo decided to scrimp on it and give it a mixed data bus. So some parts of RAM operate in full 32 bits over a 32-bit data bus. It's basically like a pipeline, if you like, transferring data from the CPU to memory. And then other areas of memory only operate in 16 bits, so a lot slower. So it's got 2 CPUs inside of it. It's got the ARM 7 and the Sharp SM83, which is used for the Game Boy and Game Boy Color. So you can see here in the normal Game Boy mode it runs at 4 MHz, the SM83, and then in Game Boy Color, if you're using the faster setting on the CPU, then it will run at 8 MHz. In total it's got 288 kilobytes of RAM, which sounds fine. However, that's split into 2 main banks of RAM. We've got one called EWRAM, which is 256K. Now this is the RAM which has the 16-bit data bus, so it runs a lot slower. We get a lot more of it, but again it's a lot slower. And then we have IWRAM, which normal stuff is kind of put in when using tonc-lib. You have to specifically specify to put stuff in EWRAM, whereas everything normally in the Devkitpro DevkitArm side of things uses IWRAM, which has a 32-bit transfer speed, or sorry, rather a 32-bit data bus for transferring 32 bits at a time. So if you've not done so already, I would go to my video on installing Devkitpro if you've not set it up already. I've got one for Windows and one for Linux. So as I've said above here, there's a 288K for us. And then we've got a big chunk of video RAM here, 98 kilobytes. And then this video RAM is pretty much shared by everything, so you kind of have to make sure you arrange things so that they don't kind of conflict. What I'll do now is I'll quickly jump over into another diagram I've got here showing video RAM, and then I'll explain what these things are. So you can think of this as our 96 kilobytes of video RAM here. So shortly I'll go into the different screen modes and rather graphics modes that the Game Boy Advance has. So we have like a tiled mode or a bitmap mode. Now each of the different modes obviously needs certain amounts of video RAM. Now specifically I will this diagram here is to show the tiled mode setup, and then at the bottom here, so this block here is actually 32 kilobytes of RAM, and this is an area where the Sprite Graphics get all of their tiles from, whether that's 16 color or 256 color tiles. Now when you are using bitmap modes, they take up a lot of memory. One of the modes takes up 75k of RAM. When you're working with a full 16-bit color screen, it takes up 75k of RAM, so that impinges on the sprite graphics. So you then lose a chunk of that. But I'll obviously get into that in a moment here. So the way that you first off, I'll talk about what these are here. So each of these slices here represents a 16 kilobyte area in video RAM. You obviously have to set switches to say which character block or char block, as they're called in tonc. Basically they are like a tile set area of memory. And then you specify which one of these each background layer should have its tiles fetched from. So you can only access 4 of these. And then what you have as well is you have tile maps. So you can think of each of these, if I zoom in even more here, so each of these regions here represents a 32 by 32 grid of tiles. So you can, there's 32 locations of these. So when you set up one background layer, when in tile mode, you have to set up where it's getting its tile graphics from, and then you also have to say where the tile map is to be fetched as well. So as you can see, these here all overlap with char block 0 here. So if you were to set up a background layer, the first one you would obviously want to, if you were using char block 0, then you would use this one here, which would be 8, which would then be outside of it. And then obviously in sprites here, they have like either one of 2 char blocks for themselves. So this will probably be more. I'll explain it more when I specifically get to the video on tiled backgrounds, and then we'll jump into it more there, and hopefully it will all become a lot clearer there. So back to this now, like so sound, it basically has, as it's being backwards compatible with the Game Boy, it has the Game Boy's APU inside of it as well, so you can do all the sounds and sound effects that the normal Game Boy can do. Plus on top of that, there's 2 PCM channels for digitized sound, which allows us to play wave files pretty much. And there's also some libraries for playing mod sound files as well. So if you've seen my video on the Super Nintendo where it's got the mod player there. It takes the same formats as those .it files. We can play those, except the Game Boy Advance player obviously is a bit better than the Super Nintendo's one. So the display on the Game Boy Advance is 260 by 160 pixels. Obviously in Game Boy mode it will revert to the Game Boy resolution of 160 by 144, and then that screen is then centered in the 240 by 160. Unfortunately, there's no way for us to actually set that specifically as one of the graphics modes. So we can either have tiled mode or bitmap mode, and there are 6 different display modes on the Game Boy Advance. So the color system, you can have up to 327,678 colors, which has a full 15-bit color palette, which is a considerable amount. And then with the six different graphics modes, we have 3 bitmap modes, which allows us to place pixels individually on the display, or 3 tile modes, which consists of tile maps made of 8 by 8 pixel tiles. So mode 1, which is the preferred background mode, which I'll be using in all of my background mode demos. We can have either 16 or 256 color tiles set to any of the background layers. So layer 1 could be 16 colors, layer 2 could be 256, layer 3 could be 256, and layer 4 could be 16. So mode 2 has 3 background layers, 2 normal ones and 1 extended. By extended I mean it has kind of like a pseudo 3D effect, kind of like the mode 7 on the Super Nintendo, which allows you to manipulate one of the background layers via some settings to skew or scale the background. I won't be touching any of that. And then mode 3 has 2 of those extended layers with only 256 color tile support on that. So regular tile maps, they can be either 32 by 32 tiles, 32 by 64. Sorry, that's not right in there. Or 64 by 32 or 64 by 64. In the extended modes, they can be 16 by 16 up to 128 by 128. So as I said just now in the other part, each tile map is 2 kilobytes in size, and they can be in one of 32 different locations in VRAM. Just come down here a bit further. So as I was saying, the all graphics almost share VRAM, which is when some of an emulator that I recommend you use is Visual Boy Advanced M. So this has a load of features for us developers. The most useful ones are it allows you to see where the tiles are. So if I in fact, I'll open one of the other emulators I've got here a minute. So if I open this demo now, so some of the useful things in here is if you go into Tools and then View Layers, but then we have a tile viewer and a map viewer. So if you go into the map viewer here and then go through the different backgrounds, this allows you to see the individual layers here. So each of these background layers are in 32 by 32. Background 0 is, unless you change it, it's always on top. Background 1 is then below that. Background 2 is then below that, and background 3 is at the bottom. So the important things here is the map base and char base. So the map base is where the tile map is. So if you keep looking here, you'll see that that number changes for all of them. But the char base also changes for these as well, as the this image here uses 448 tiles, so that actually has its own char block all to itself. This one has its own char block to itself as well. So notice this is a different character block as well. So this is a 256 color image made of tiles here, as is this one here. Whereas background 3 and background 0 are 16 color modes. See, like it says there, 16 colors, and they basically share the same character block, but obviously they need to have their own different tile map set up in VRAM there. So if I show you some other things on here as well, so we've got the OAM viewer. So OAM is sprites basically. So as you can see here, it's showing the sprites. Not really sure how this is set up here, but anyway, I'm guessing it kind of is actually showing the whole sprite RAM possibly. This is the first time I've actually looked in the OAM viewer here. I wasn't expecting that. So another, if I get out of this now, like, so another emulator I have as well is, where is it? MGBA. So if I quickly boot that one up a minute. So we didn't get the sound in the other one. I didn't notice that. Oh yeah, I forgot about that. Yeah, I've put, this has everything in it from a game I recently sort of created and released on itch. So most of the stuff is still in the demo, the code, as in the bare bones things. So this is what I was actually expecting here from the Game Boy one here. So the Game Boy Advance has 128 sprites. Don't think there's any issue with them all being on the same scan line. So we have like priority flags here. You can flip them left and right sprites. And then we can see I'm changing the frames for them here, like hence them all animating. So you can click on a specific sprite and it will give you the location of it. I haven't checked whether this one here is available for Windows or not, but I'll come back to this in a moment. So it's important to be aware which char map and character block we're using, and the emulators can help us make sure we have them set to the ones we believe they're set to, and also to see how they're displaying as well. Obviously, if you set things up wrong, then you'll get all kinds of garbled graphics on the screen. And then also, like I was saying as well, with the bitmap modes, mode 3 here allows full 16 bits per pixel. Obviously we can only use 15 of those, but that takes up 75k of RAM. I've not put how much each of the background modes take up here. This is just a quick oversight for everyone, really. Each of the individual videos, so I'll probably do an individual video on 16 color tiles, then another one on 256 tiles, and then one with them mixed, and then go through the two main sort of bitmap modes here, which is mode 3 and mode 4. So in mode 3 here, this gives us 16 bits per pixel, but it means we can only have one screen in VRAM. So you're probably only going to want to use that maybe for like a title screen, or I suppose if you were doing sort of like a graphic adventure game or something of that sort, that could be fine, because if you were to update stuff quite quickly on the screen, then there's a chance there would be graphic tearing, because you're only working on one layer which is being shown as well. Whereas in mode 4 it has 8 bits per pixel, so it's 256 color mode, but what that means is that one mode 4 screen is half the size of the mode 3 screen. So we can have two screens in VRAM, which means you can have one screen being displayed while you update the display on the other screen, and then flip them over to allow us to create double buffering. So I'll quickly get back to the tiles here a moment. So in 16 color tile mode, you can have 1024 tiles per char block. And then the tiles themselves, when displaying on the tile map, you can mirror them both horizontally or vertically. And then the 256 colours you would then treat as segments of 16 colours, which we would call a 16 colour palette. And each 16 colour tile takes up 32 bytes of VRAM. When we switch, or rather if we have 256 colour tiles, then each tile has 1 byte per pixel. So that means that one 8x8 tile will use 64 bytes. So when in 256 color tile mode, we have the amount of tiles in one character block. So that is something to be aware of. And again, with different settings on the tile maps, we can mirror the tiles horizontally or vertically. And each background layer has a priority flag as well. So normally in mode 1, as I said before, background 0 is at the top and background 3 is at the bottom, but you can always change a priority flag so they're altered, so one would then render above another. So another thing to be aware of in bitmap mode 4 as well is you can only write to VRAM in words, which means 2 bytes at a time. You can't write any 1 byte, it has to be 2. And then also when we're working with bitmap modes as well, they will extend into the sprite graphics area. So if you are using sprites in bitmap mode, then that halves the amount of tiles you have accessible to you. And then getting into so there's also another area of RAM as well called palette RAM, which holds 2 palettes of 256 colors. So in another thing as well is which I haven't mentioned as well is when working with tiles as well, you have a 16 color palette, but color 0 in each of the 16 color palettes is considered transparent, except for the first palette where color 0 would be the background for the whole screen. So getting into the palettes here, so there's one 256 color palette which is shared for all the background layers. When you're in mode 4, which is the 256 color bitmap mode, each of the pixels on the screen gets its colors from the standard color palette for the backgrounds. So there's one palette for backgrounds and one for sprites. And the format is this here. It's pretty much the same as the Game Boy Colors format, where we have 5 bits for blue, 5 bits for green, and 5 bits for red. So red, green or blue can have a value between 0 and 31, with 31 being the brightest setting. So I've already sort of gone over this here, so I'll go over the sprites. So you can have 128 sprites in total on the Game Boy Advance, and they get their graphics from the last 32K of VRAM. They do have their own area of memory called OAM RAM, and that just consists of attributes for the sprites, so their horizontal, vertical positions. If they're using 16 color tiles, then it specifies which palette they have. And then there's also some attributes there for their shape and size as well. So you can't just set any size, there are predefined sizes for them. So you can either have squares of 8x8, 16x16, 32x32, or 64x64. Or you can have rectangles using these specific sizes here to make up their height and size. So that is per each sprite, by the way. It's not like on the Super Nintendo where you could only specify 2 sizes. Each sprite can have a different size. whether that be square or rectangular, and they can also vary whether they're 16 color or 256 color as well, which is a nice thing to have. So I will now go back into our example program in more detail here. So got the turtle doves here, which are the 16 color sprites bouncing around, and then we have background layer 3, which is creating a color gradient background for us. And we have 256 color tiles making up Mario and Luigi picture here, and then a Game Boy Advance 256 color image in the background 1. Sorry, no, that's background 2 actually. So this pretty much shows off some of the nice capabilities of the Game Boy Advance here. So I think I've also, in this demo, which I will link the source code to, I also, I think, there we go, yeah, I thought I did. I've assigned a sound effect to play when you press one of the buttons as well. So there's 2 sound samples included with this demo as well, and then obviously we can have a look at everything here. So here's our background palettes here. So I didn't use all the 256 colors, so the one of the images here has 128 colors, the Game Boy color picture here, sorry, the Game Boy Advance picture. The Mario and Luigi, they have 64 colors, and then I have a color gradient at the end here using palette 13. So when you mix all of them together, like, you just have to try and remember or make a note of where one image's colors start and where they end, so that the colors can be separated. And then we also have the sprite palette here as well. So these are 16 color mode as well, and you can see that they're not using the full range there either, but we have plenty of resources to work with when it comes to the Game Boy Advance, which is good. So that is it for this video. Hopefully I'll have some interesting stuff to show in the future videos coming up. So if you've I'll leave links to Virtual Boy Advanced M and the tonc lib documentation as well, and the source code for this demo as well. Won't go into any of the source code. I'll talk about that in later videos. All of it is built on top of various stuff from the tonc.lib site, and it also uses a sound library called libmad as well. In one of the other videos, I'll also when I go into sound, I'll show how we can use the APU on the Game Boy to create sound effects as well. So also, if you found this video useful as well, then I'll leave a link to buy me a coffee, so you can supply me with some caffeine to keep me going with my coding and video efforts. So Yeah, I'll also leave a link to my itch site as well, so you can see a game that I created for the Game Boy Advance on there, which uses pretty much most of the code that's in the demo that I just showed, so you can see what's possible. So that's it for this video. If you have any questions or anything, then leave them in the comments and I will get back to you when I can. Right, catch you later.